Free response question number 4 says the height of a tree at time t is given by a twice differentiable, and that's important, twice differentiable function h, where h of t is measured in meters and t is measured in years, and selected values of h of t are given in the table above. Part A says, use the data in table to estimate h prime at 6. Okay, now when we're estimating h prime at 6 on this table, we need to find where that 6 is. And 6 is right here. T equals 6 is between 5 years and 7 years. And it says, using correct units, interpret the meaning of h prime 6 in the context of the problem. So first of all, we're estimating a slope of h. And to do that, at 6, we're going to use the adjacent points. So to estimate, we're going to use the average slope between the adjacent points of 6. So between t equals 5 years and t equals 7 years. And we're going to calculate that average slope. So we're going to say this. H prime at 6 is going to be approximated by h of 7 minus h of 5 over over 7 years minus 5 years. And when we do this calculation, we're going to end up with 11 minus 6 over 7 minus 5. And that gives us an average slope of 4 over 2. And when it says using correct units, interpret the meaning. So using the units, h is measured in meters. So that's going to be 4 meters. And t is going to be measured in years. So that represents 2 years. Okay, so the h prime of 6 is going to be the average slope, which is 2 meters per year of growth. For B, it says explain why there must be at least one time t between t equals 2 and t equals 10 where h prime is equal to 2. Okay, so some of the wording here is very useful because it says at least one time. That's kind of indicating that we're probably going to need the mean value theorem. So we want to make sure that we have the conditions for mean value theorem. So we need to have a function h that is smooth and continuous. And because it's twice differentiable, it means then that this function, so the twice differentiable function h, means that this function is smooth and continuous, so it meets the conditions of mean value theorem. So applying mean value theorem here, mean value theorem, we're going to look for some intervals where we can see an average slope of 2. So we know that mean value theorem is going to look like this. H prime at A is going to be some average slope between, we'll call that C and B, and in the interval between B, C, and B. Okay, so looking at this table then, what I need to do is find an interval where I can see a slope of 2. So I can find that here between t equals 3 and t equals 5. Okay, so we have an average slope of 2 here. We already calculated between t equals 5, t equals 7. There's an average slope of 2 as well. So we just need to choose one of those intervals. In this case, I'm just going to stick with the interval between 5 and 7. So we know that the h prime at some point A, or we'll just keep that as t, h prime of t equals 2. Okay, and that interval is going to be, we're going to use between 5 and 7. So we know that h of 7 minus h of 5 over 7 minus 5. And again, we've calculated that above. That's going to be equal to 2 meters per year. And we know that t then must be in the interval between 5 and 7. Okay, so there must be at least one point between 5 and 7 that the slope, the instantaneous slope, or the derivative is equal to 2 meters per second. Taking a look at the mark scheme here, for A, we get 1 mark for the estimate and then interpretation with units. For B, we need to use the average slope and make our conclusion using mean value theorem. Okay, so based on the mean value theorem, we can use this result here.